Welcome back to Bushy's Projects. In today's video, we're going to turn this piece of 5160 into this little mini axe. All right, so we've got our little template drawn out. This is an old template. I've changed the design slightly, so what we end up doing is actually giving ourselves a little bit more material for the blade. We go here, but then we just go a little bit higher up, so it gives us a little bit more across our... See, as you can see, the way it's thinner back here and wider up here. Now this part here, where we've cut these little notches in, or we're going to cut these little notches in, that gets squashed in and becomes the handle. This gets driven around, the blade comes around, and then we forge our blade out. Pretty straightforward, a lot of banging. Let's get into it. Just to make sure the angles are good. And just grind it a tiny bit. So throughout the process of making these little axes, we're going to be using the power hammer. Now this power hammer, I've built from scratch. I've built it from scrap metal and random parts. So the bearings, they came from a table saw that I bought off this old guy. The spring on top there is from my mate's Colorado. Actually took the spring apart and re-stacked the leaves to suit the machine so that it's got the right rigidity, it's not too slack. This is just a piece of random offcut steel that we've purposed for that. The ram itself is solid, which we cut and then welded the dies to it. The dies themselves, these little blocks here are from a piece of equipment up in Darwin that I scavenged and brought all the way back down, and then forge welded and stick welded the hard face dies on there. They're 5160. The electric motor is from my old boss in the Riverland. The tyre and the bearings are from an old Mitsubishi Colt from the Riverland that we used to rally when I was a kid. The thread and the nuts, that's from the same guy that I got these scrap bits from. This is the mount for the spring. The bolts, the original from this. The pipe work itself is left over from the firefighting system in the local Cheapest Chips in the Riverland that my mate scavenged from the scrap bin and gave to me. The section here for the middle at the bottom was given to me by my dad's cousin. This is a truck chassis. They're the offcuts from the end of a truck chassis from when I was working for Stefan DiFrancesco in the Riverland and his trucking, his engineering business. This is a sway bar off of a caravan that I picked up from somewhere that I stretched out, forged out and shaped to become the pedal to control the motor. Pretty much it. So if you like this, please subscribe. We are going to be doing a series on how to make one of these power hammers in the future. Alright, so step one out of the way, we need to put the drawing dies on and start on, step two I guess, to stretch out that handle and then flip it around and stretch out the blade. right, so by this stage, you probably noticed we're actually doing 2 axes, and that is so that we can get all the different camera shots and different angles. So it doesn't actually take that much longer to do 2 because you don't have to wait for your steel to heat up. While you're working on one, the other one is in there getting nice and hot, ready for the next pass on the hammer. Looking pretty good, that one. Pretty happy with that. Kept a little bit of angles going on there. It's usually the way. That's quite straight, actually. Usually with axes, they get some crazy twists and very tricky, like little kinks and stuff, right where you don't want them. And this material, this 5160, is super tough, so to get things to move and twist them, you really need them almost at a yellow heat to like comfortably hammer them around. When you work with railway spikes or a lower carbon steel, it's like you can almost just hammer them cold and get them where you need them, but this stuff's really tough, so. All right, so both of those blades are 90% straightened. There's no point fully straightening them until after we've done a bit of grinding and we expose the material that we're going to actually have at the end of the process. So right now they've both had a good bit of heat. They're doing their first kind of, it's called a normalizing cycle or a thermo cycle, where they've been brought up to temperature, taken out, and they're let to cool down. They say down to room temperature, but I just go down to 200 degrees, so below 200 degrees. Now, a good way of seeing is if you drip water and it's just bouncing off like that, and it's not sticking, that's above 200 degrees, right? So as soon as it starts to stick and sizzle, like this one, see how it sort of sticks on there and it's sizzling a bit? It's not just bouncing off and shooting away. That's pretty close to 200 degrees. When it hits it and it really sticks and slowly sizzles, then that's when I'll put it in the bucket. So yeah, probably about 150 degrees to be fair. Now, judging temperature is quite important for a vast range of processes. Different steels require different temperatures. Some steel, if it's over 0.85%, it's becoming a hyper-eutectoid steel. You can crumble that steel by giving it lots of high temperature soaks at high heats. And the higher you go with carbon, the more likely that's going to happen. Another way you can ruin your steel is if you just straight up burn it. You know, it's in there, it's really hot. The burner's sucking in oxygen and fuel and mixing it. There's always a bit of extra oxygen, and that will interact with the steel at high temperatures and cause it to just start to fizz up and burn. So you need to watch out for that too, especially with carbon steels. Overheating this steel will ruin the steel, all right? So, you know, everyone thinks folding the steel purifies it, but actually modern steel is as good as it's going to be straight out of the mill. You do not want to mess with it unless you're obviously doing Damascus, but you really just want to keep it within a safe working range. All right, so this axe, it's cooled down enough. As you can see, the water's sticking, it's still fizzing away, so it's over 100 degrees. But that's safe now. It's below that 200 degrees. It's not going to harden, it's not going to warp, it's not going to crack by cooling it down. Now, we cool it down so that we can do some grinding, a bit of marking up, a bit of cleaning up. And then we're going to go back in for a couple more thermo cycles. All right, these little axes are ready to thermocycle again. Time to fire up that forge again. We did 2 Thermo Cycles on these. Now, partly because I did control the temperature quite well in the forging process, so I'm not too worried about the grain blowing up. You could do a third one. So rather than doing a whole third one, we're going to bring it up to temp, we're going to bring it out, we're just going to let it cool down a little bit, then go back in again, bring it up to quenching temp and go into the quench. Now, I'll get this forge going and I'll explain a little bit about what's going on with the Thermo Cycle. The process involved, the physical process, is getting the steel up to a particular temperature. Usually, well, there's 2 ways to do it. You can do a subcritical Thermo Cycle. It does have a slightly different effect, but you want to go over that temperature slightly and keep it like not too much above it for a good couple of minutes, depending on the steel and depending on also what's happened with that steel. If it's been overheated and it's like been worked at high temperatures, you're going to have to do at least 3, and you're going to have to keep it at that temperature for at least 5 minutes in each cycle. If you're pretty happy and each time you've heated it, you haven't overheated it, you can get away with a few minutes less. If you really want to get crazy and optimize it, you need a heat treating oven. You need those temperatures to be bang on. You need the timer to go off. You need all of that stuff to really nail it, absolutely nail it. But for what we're doing little handheld axes. We're not doing super fine blades, so there's a lot of wiggle room there. And the performance of these axes, once we're done with our process, is going to far exceed what is actually required of the tool in the human hand, as far as braking, as far as edge retention, as far as functioning as a tool. So I use this material a lot. I'm very familiar with it. We make our cleavers from it, we make our axes from it, and I use it as a core steel in our sand mire when we mess around with that sort of stuff too. And like I said, we're not doing a very thin blade. 5160 is not suited for that anyway. It is an impact steel. It's one of the toughest steels around. And also, yeah, it's not too complicated for a backyarder to kind of get a grasp of the process. So we're just bringing our edge up a little bit. See that little bit of color on there? So we'll just get that temperature up on that edge, and then we'll bring them out, let it kind of soak back through, because these have gone cold now. And what I want to do, we'll go one at a time. We'll put them back in with a thick end in the flame, and we'll watch our blade. We'll make sure the blade's coming up to temp. We don't want the whole thing coming up to temperature. We just want the blade coming up to temperature. So there we go, a little bit of color on there. That's telling me there's a nice bit of heat in our edge. I'm going to flip it, put the blade away from the bulk of the heat. We're going to open up our quench bucket here. So this is a combination of canola oil and rice bran oil. The old vacuum cleaner, nothing goes to waste. You see an old vacuum cleaner, I see a steel bucket. So we've gone over it with the coarse wire brush on the hand grinder, got most of the scale off, pretty much all the scale off, got all the oil off. It's still got this kind of grimy surface, but the next step, we're going to grind a apex on here, quite a steep angle, to find our center line for our blade, right? After we've done that, we're going to go over here, we're going to grind some clean steel on, so some flats on the sides here, just enough to clean it up. Then we're going to get the torch and temper it. So the forge burner itself is going to act as a torch, and we're going to bring some heat right up through the blade. Then we're going to clean it off, and then we're going to bring the heat through again. They call it a torch temper or a ghetto temper, I guess because you can do it in the ghetto if you happen to be short on the right equipment. I've yielded some very good results from this double temper. We'll do some testing on these at the end just to show you guys kind of what they can hold up to. So to check the hardness, we get a file, and we run it across, and if it's biting, which this is absolutely not, then it's too soft. So right now, you can hear it. it sounds like a ceramic tile. So even when I come right back on this sort of sharper bit of the file, it's not cutting it. Okay, so right back to about here, it's beautiful and hard. Now, it's actually a bit too hard and a little bit too brittle. So what we need to do is soften it up a little. And the way to do that is with heat. So you want to soften it, but only in like relative terms. So when I say soft, it's still going to be really, really hard. It's going to be losing probably about 4 or 5 points at most of hardness. And it's still going to be like incredibly hard, but it's going to become very tough. Choke her up a bit. Turn it down a bit. Put that on. First, we just want to get a bit of heat into this bit back here. Takes a few minutes. Do both at the same time, actually. Bit of heat in both. Bit of heat back there. Also a bit of heat in there. So we want to heat the back up quite a bit and bring it forward to that cutting edge. Glue under the blade there. Now, they are probably a bit hot still, yeah, so we'll just cool them off. Ready for grinding. All right, ladies and gentlemen, here we are. We've just pretty well finished our grinding. Everything's shaped up, everything's feeling all smooth and nice. They are very shiny though, they need to be etched. If you leave it like this and you put some oil on it, the oil's not gonna stick. The wax is not gonna stick. It's gonna come off and then expose that raw, clean, shiny steel straight away. As soon as you use them, they're gonna tarnish. So we are gonna preempt the tarnish by adding a patina. Now, there's a lot of ways to do this. Kind of like in our first videos, if you've been with us from the start, we do an electrolysis etch. Now, we've moved up in the world from our original setup to a much larger setup. So the trick here is about 12 seconds at 140 amps and give it a jiggle so we don't pick up all that stuff that's on the surface. See how it's gone all dark? So there is a bit of extra oxide on the surface that we need to wipe off. So that's one done. Put it in the water. And you can dip it back in for another 12 seconds to get a slightly darker etch, but it's barely any different really, to be honest. So we wipe off that oxide, you can see the difference there. And we've just got a nice grey matte finish underneath. So I'm just wiping this off in front of the camera so you can see. But yeah, you can see even here, like if I go like that, it's taking it off. So we'll get most of it off. I'll chuck it back in the water, because we do need to take this to the big quench bucket and really make sure all of that salt water's gone. Because any little drop of salt water that's still on there is going to create rust really quickly. All right, so just a quick sharpen. It's already pretty sharp, so we just give her a couple of swipes, make sure there's no burr on there. That one too. So I'm using the light to get my angle. Might do a sharpening video at another time, I reckon. See what people think in the comments. Not going to go into it now. Yeah, it's a quick little swipe, and then I've got a bit of stropping compound on here, so that's this stuff here. It's like a ceramic suspended in a chalky wax. I don't know what it is, but it works really, really well. A couple of good swipes, and then just a quick little to take off any little last bits of that burr, and then back on the strop. Once you've done one, make sure you brush any little bits of burr off before you go to the next one. Quick clean up. So the basics of sharpening is you bring your steel to a nice apex and make sure that apex is clean. Get rid of the burr off of it. You can feel the burr if you go like this. Yep, feels pretty clean. One more little strop. And then, so the paper test, it's a pretty good test. It'll give you an idea of your edge. You can hear how it cuts. And the first few slices are usually a bit rough because you've still got a little bit of something, you know, hanging on that edge. In here it's pretty good. Keeping in mind it's an axe, it's not a knife. All right, so if it was a knife, I'd expect it to cut very cleanly. So what we can do now is a quick test. So you saw both of those cut through pretty well. I'll give them a last little strop now that it's kind of cleaned off that last bit of that burr, and we can go crazy on a bit of pine. I'll go and get a piece of, it's like 50 by 50 pine. It might even be thicker than that actually, about 60 or 80 by 80. And we'll go over to the wooden bench. So quick little before. Not too bad. Make sure there's no nails in it. We look pretty good. Give that whole blade edge a good working over. All right, moment of truth. It's the first take, so I hope it's still sharp. I feel like the humidity has a lot to do with the paper not cutting sometimes as well, but that's still pretty good. I reckon give that a quick strop, it might even shave hairs still. Oh, not quite. So it has lost a tiny bit of that edge. This steel is not the best steel for retaining a really fine edge. It is one of the best steels though for retaining a working edge for chopping heavy duty stuff. So we'll do the same with this one, just quickly. We'll do the same with this one, just a quick little test, make sure we're still cutting paper. It's like nothing ever happened. If not, it feels a little bit sharper actually, which is a phenomenon that once you clean that edge off sometimes, it will create like little micro serrations and it'll cut even better. So there you go. We'll give these a wax up, get some final shots, I guess. And if you like what you see, like and subscribe, hit the notification bell. Otherwise we'll be lost in the YouTube abyss. See you next time.